Welcome, everybody. I'm Craig Cornu, and I work at the Institute for Applied Ecology. I live here in Coos Bay, and I serve as the project lead for the projects that we're going to be talking about today. I also coordinate the Pacific Northwest Blue Carbon Working Group. So I hope you have noticed that there's food and coffee in the back of the room. So Ed is demonstrating the coffee situation there. So feel free to keep noshing on that. I want to start by thanking the South Sioux Reserve for hosting this in their wonderful facility here and for arranging a beautiful day. You guys are very complete in your preparations. Okay, so before we get started, a couple quick thoughts about logistics. You may hopefully have noticed that Wi-Fi and password here and in the back there for the all-important connection to the outside world. And you've probably already met John Bragg from South Slough out at the front there. And we've got a sign-in sheet there, so make sure that you sign in and name tags, etc. Also, restrooms are out the front door and across the breezeway there. So that's pretty much it for logistics. Okay, so the other thing is you've probably noticed that we're videotaping this, and that means that, hang on one sec. Hey, there is, and we have people participating remotely, and one of you folks might want to mute your microphone because we're hearing some crashing and burning. Actually, can one of you from the remote world say something to make sure that we can hear you?
Are we muted? Is that why it's red?
Yes, it's muted. That's why it's red.
Yeah, but. Okay, can you try that again? Uh-oh. Hey, Dick, can you hear me?
Yeah, I can hear you now.
Okay, cool. All right, so you couldn't hear anything up to this point?
Correct.
Okay. Hey, well, we've just done introductions to the meeting and a little bit about on-site logistics. So you haven't really missed anything because you're not on site. Okay. So we'll introduce you guys in a moment, but back to the show here. Let me get back on track. Okay, so for those of you who are in the room here, you'll notice that we are videotaping this for folks who aren't able to participate either remotely or in person. So we have something to share with folks. So importantly, as part of that videotape, we're going to need to talk into a microphone whenever we're talking. I'm all mic'd up here, and all the presenters will be mic'd up, so that won't be a problem. But when we do introductions in the room, we'll be passing around a microphone, so that's how that will work. And then we've got two other microphones, so whenever there's interactions, questions, if you can grab the nearest microphone, that would be really great. Okay? All right, so before we get to those introductions, I wanted to quickly set the stage and give everybody some background on these two projects that we're going to be discussing, just to make sure that we're all on the same bus, as they say. Last time a bunch of us were in the room, we were only really talking about one project. So, all right, but first, a little bit about the Pacific Northwest Blue Carbon Working Group. Both of these projects we're talking about are working group projects, and the group was formed in about 2014, largely in response to the release of the Verified Carbon Standards Blue Carbon Methodology for tidal wetland restoration. And the idea is that the working group takes a collaborative approach to collecting the data that are needed from the Pacific Northwest to go into that methodology so we can develop blue carbon projects or carbon financing in the Northwest. The group is, as you see here, a group of scientists, coastal planners, land managers, et cetera. So an all-encompassing group of end users who are interested in this, all weighing in on how this work gets done. We're so collaborative that we have, and organized, that we have a website and a Twitter account. And I can tell you that the website has been in existence for, I don't know, maybe 8 months or a year. And it's been pretty handy. We've had some people express interest in what we're doing. And in particular, Chris Janicek has been the main Twitter account person, and he's been using that, as he'll explain a little bit later, in contacting folks about blue carbon data, and that's been pretty handy too. Anyway, so those are out there. All right, so the overall goal of our working group is essentially to facilitate the development of blue carbon projects in the Northwest. So we can add tidal wetland restoration to the regional climate change mitigation actions. And to that end, the working group has developed both biophysical and socioeconomic research objectives, and those are outlined in a framework we developed in 2015. So straight off the bat, we jumped into an effort to collaboratively develop a bunch of research proposals on the biophysical side, and we ended up being awarded in 2016 from the Near Science Collaborative for the first project that I'm going to be telling you about, and that was the Pacific Northwest Carbon Stocks Assessment and Database Development Project. So that project was developed, was designed to mainly address these working group goals here. And here's a quick snapshot. You're going to hear, you're going to hear more about that later this afternoon. But basically, we have lots of partners and a big list of objectives and a whole bunch of sites. We've taken quite a comprehensive approach to doing this work. So the idea here was that carbon stocks, on the biophysical side, carbon stocks were to be the first of the regional blue carbon data that the working group would tackle, understanding that research quantifying greenhouse gas emissions and carbon sequestration rates for tidal wetland wetlands in the Pacific Northwest are the other two major data gaps that we need to close, and those would be addressed in subsequent research proposals. So that's what's going on that side. And then on the socio-economic side, we have some goals that we decided to fill with a 2018 working group proposal, also submitted to the Near Science Collaborative. And that project is designed to take advantage of the new data being collected by the Carbon Stocks project, in addition to existing data that exist out there to assess how these projects can actually work on the landscape. So that project was designed to address the objectives that were up there. And again, here's a quick snapshot. And the idea here, again, is to give end users from both projects an early peek as to how blue carbon valuation works and how projects might unfold in the Northwest, and importantly, to expose any data gaps and other issues that need to be resolved in order for these projects to happen out here. And this is just a slide showing you how these projects line up on a timeline. We're here in October somewhere, so both of these projects are quickly coming to a close. We're wrapping these things up, and that is what we've got going on. So it needs to be noted that both projects have been undertaken with the participation of a long list of project team members and guided by perspectives of a whole longer list of end users, and also facilitated by the South Slough Reserve and Padilla Bay National Estuary Research Reserves. Without all of those people being involved, none of this happens. And it also goes without saying that it's been nice to work with the Near Science Collaborative, because their support and resources have been pretty central to what we're doing here. Okay, so let's quickly go over the agenda. Hopefully you guys have had a chance to look at this, but basically this morning we're going to start off talking about the feasibility project, the second project that I'm talking about here, and then in the afternoon we'll switch over to the Carbon Stocks project, discussing results and implications there, and then we're going to wrap up at the end to talk about next steps, the all-important next steps. So we do. Both of these projects have exposed some data gaps, so we have more work to do. So the idea is that we put our heads together and figure out how that work gets done. Okay, so you guys have any questions? All right. Let's do introductions, and what I'll do is start with the remote folks, so that we can get you guys included here. How about this? I will call your name, and you can unmute yourself. It would be handy if you could mute yourself until I call your name. That includes you, Jason. Thank you. Jason, there's something going on with your microphone or something. We're hearing a lot of things. Okay. Well, since you're at the top of the list, Jason, why don't we start with you after I've given you a hard time here. So please introduce yourself.
Thanks for the sound. My name is Jason Knuckles, work with the Nature Conservancy. I work on floodplains and estuary restoration. Happy to join. Thank you, and I'll stay quiet.
Well, it's not you we're worried about. We're worried about what's happening behind you. Okay, Dick?
Morning, I'm Dick Vanderschaft, also with the Nature Conservancy. I work on estuary restoration and nearshore marine reserve conservation work.
Thanks, Dick. Next, we'll go with Melissa.
Hi, can you hear me?
Yes.
Great. My name's Melissa. I am just finishing my PhD at UC Davis's Bodega Marine Lab, and I've been working on blue carbon stock assessments in seagrass meadows and salt marshes. And I've been working with Chris on the data set that you mentioned, so he tipped me off to the meeting.
Great. Last but not least, Scott. Scott, are you there? Yes.
Can you hear me?
Yes.
Yeah, I'm Scott Jones. I'm a postdoc with U.S. Geological Survey, working on a national carbon assessment and also doing the Pacific Coast plant ecology. This also tipped me off, so thanks, man.
Great. And can you, Scott, while you're unmuted, can you guys hear us okay?
Yes.
Okay. All right. So for the people in the room, it's time to pass the microphone. So we'll start up here and just let us know who you are.
Good morning. I'm Narayan Lavmar with Columbia River Estuary Study Task Force, or CREST. I'm a habitat restoration biologist, so April and I, we monitor all our juvenile salmon habitat restoration projects in the Lower Columbia River.
April Silva with Crest. Like Narayan said, we do a lot of tidal wetland restoration projects, so we're very interested in the work that you guys are doing.
Hi, I'm Cindy Park. I'm with the Coos Watershed Association. I'm a local restoration biologist, primarily working with private landowners, and I do have a number of estuary restoration projects.
I'm Kelly Warren. I'm the Western Oregon Regional Biologist for Ducks Unlimited, and we do also a lot of restoration projects and looking for more.
I'm Chris Janicek. I'm with Oregon State University.
I'm Jenny Schmidt. I'm with the South Slough Reserve, and I coordinate our Sentinel Site program, which is looking at how wetlands are affected by sea level rise, and then I also do the post-restoration, pre-restoration monitoring for the reserve's restoration projects.
I'm Amy Bordy with Pacific Northwest National Labs. I'm a wetland ecologist, and I've been a part of the blue carbon stock assessment team.
I'm Heide Diefendorfer, also with Pacific Northwest National Lab, as well as the University of Washington, and also a member of the Blue Carbon Stocks Assessment Team.
Hi, I'm John Bragg, Coastal Training Coordinator for the South Slough Reserve. And for this project, I did the needs assessment that we saw at the beginning of the project a couple years back.
Good morning. I'm Amy Horstman with U.S. Fish and Wildlife Service.
I'm Megan Hilgart with the NAR Restoration Center. I'm based in Portland, but I support the projects that we fund out on the coast.
I'm Ed Hughes, local fish ecologist with the Coos Watershed Association. I was focusing on juvenile salmon life histories in the tidal zone.
Hello, I'm Sean Schooler. I'm the research coordinator at South Slough and just interested in research around blue carbon and carbon sequestration.
Hi everyone, my name is Neha. I'm the research scientist at the Lower Columbia Estuary Partnership, and me and my colleague here, we monitor the tidal wetlands around the Columbia River crest.
Sarah Kidd with the Estuary Partnership, and as Sneha mentioned, we do a lot of monitoring of reference wetlands and restored wetlands throughout the estuary, and we're also very interested in thinking about carbon.
Hello, my name is Fran Recht. I'm with the Pacific States Marine Fisheries Commission's Habitat Program, and I'm on the Pacific Marine and Estuarine Fish Habitat Partnership along with John Bragg.
Mark Healy, Coquel Indian Tribe. We're interested in eelgrass monitoring, restoration, and any kind of carbon sequestration projects.
Hi everyone, I'm Steve Emmett-Mattox. I've been with Restore America's Estuaries on and off for the last 20 years. I also have a small consulting firm, and I've been involved in blue carbon in the U.S. primarily for quite a while.
I'm Laura Brophy. I direct the Estuary Technical Group at the Institute for Applied Ecology, and I've been doing a lot of on-the-ground work to understand our tidal wetlands in the Northwest, and then mapping and planning to try to advance our restoration success.
Morning, Steve Crooks with a company called Silvestrum, and I'm also with the Smithsonian Environmental Research Center. And I'm what do you call it, end user on the main science program, and one of the technical leads on the carbon project feasibility assessment. We work on, I come from a wetlands restoration background, but now we work on trying to translate information on climate change and what it means for urban, but also particularly landscapes in coastal settings.
Good morning, my name is Bree Yadnock. I'm the reserve manager at the South Sioux Reserve, and I'm an end user for both of these projects, and on the project team for the Blue Carbon Stocks project.
Hi, I'm Katrina Poppy, research associate from Western Washington University, and I've worked on a number of projects sort of doing the field and lab work, particularly looking at carbon sequestration rates. And including the Snohomish estuary project that's included in these.
Good morning, my name is Lisa Schile-Beers. I'm a wetland ecologist working at Silvestrum and also at the Smithsonian, and I am on the technical team for the carbon finance assessment.
I'm Scott Bridgem. I'm a professor at the University of Oregon.
Good morning, I'm Scott Suttlemeyer. I'm with Terra Carbon. I'm part of the team that looked at the carbon project feasibility here and up in Washington. Terra Carbon is a consulting firm. We do work on carbon project assessments, registrations, monitoring for forest wetlands and agricultural lands as well.
Great. Thanks, you guys. You can hang on to that. So a couple things to keep in mind about the microphones. You'll notice that we're not using a PA system here because this is a small enough room, small enough crowd that I think we can hear each other. So these microphones aren't helping with that. So make sure that you do speak up so the folks remotely can hear you, because this is where the microphone is for them. And if you guys don't have any questions, we're ready to get started with Steve Emmett-Mattox. Are you all mic'd up?
I think I'm mic'd up.
Okay.
We're doing good? Okay. And how do I?
I will do this for you.
Is this the advancer?
Yes.
That one?
Yeah.
Okay. Thank you. Well, while he's loading that, I will just say this is an exciting time for blue carbon, and it's really great that we're here to kind of wrap up these two projects, which have contributed just a ton of information about our understanding on the science side, blue carbon dynamics in the landscape across a different range of settings, and you'll hear all about that this afternoon. But also on the feasibility side, our goal from the beginning has been, how can we use blue carbon as a catalyst or an added incentive or an additional source of funding, or you name it? How can we use our understanding of this ecosystem service as a way to promote more restoration and conservation of these vitally important ecosystems? And that's always been why we're so interested in blue carbon. When I say we, I probably mean myself, and I make assumptions about others, but I definitely mean Restore America's Estuaries, and at least, I think most of us, that's really what the interest is. Okay, that doesn't. The right button?
The one on the right?
Yeah. Here, there.
It was working for me.
We can get this way.
Interesting.
Nothing's moving it. Oh, there we go. Okay, maybe it just was. Okay, got it. Thank you. I do want to take just a moment to acknowledge the funders. Craig mentioned, I think the overall funder for both efforts has very much been the National Estuary and Research Reserve System Science Collaborative. They've been an important funder for blue carbon work in several places across the U.S. But I also want to acknowledge that Restore America's Estuaries and the Wildlife Forever Fund contributed some money more around the outreach collaborative side for this project, for the feasibility work. So that's my goal for the next 5-7 minutes, is to really introduce that piece of the work. How many of you were at the workshop we did at the end of January, early February, to kind of kick off the feasibility work? It's not a stretch. Okay, great, thank you. So, as I mentioned, our blue carbon strategy has always been about supporting, ultimately, more, better, faster, stronger, right, restoration and conservation of these coastal ecosystems. The way that path is about improving our science and our quantification, our understanding of greenhouse gas dynamics in these ecosystems to support better policies, better management, new financial opportunities, and more persuasive advocacy and communications. And really what we're doing is trying to build a portfolio of our understanding of coastal management of these greenhouse gases and different options. And so we've done feasibility work in several places in the U.S. The core project team has been part of many of those. Scott at Terra Carbon has been part of all of those. So this room right now has the expertise in what is the market feasibility of doing blue carbon offsets as a way to help enhance the restoration actions we want to take. And I'll just mention a couple places where we've been doing that work. Cape Cod, there's a potential 1,000-acre tidal wetland restoration called the Herring River Restoration. That's a very exciting restoration project. All by itself, it doesn't need blue carbon to move it forward, but there's potentially a pretty good net greenhouse gas benefit at that project. Rookery Bay down in South Florida, also tied with another National Estuary and Research Reserve there. They're looking at mangrove restoration and restoring hydrologic connectivity to conserve and restore mangrove systems, and there's a potential blue carbon benefit there. And then there's other places. And I won't go into details. If you're curious about those, just approach really either me, Scott, Steve, and you can ask us about those opportunities. But what we're doing is we're taking everything we're learning from all these different places, and it's kind of helping us, I think, get a much clearer picture about where we should be heading. And that's why I think this project is exciting, because it's part of that effort. The context nationally and globally for this work, it's not just about what can we do here in Coos Bay. It's also about, how does this fit into the bigger picture of what's happening? So in the US, you may have heard that a couple years ago, for the first time, any country ever has included blue carbon ecosystems in their national greenhouse gas accounting. So if that's not something you're familiar with, basically every year, the US Environmental Protection Agency does an estimate of the US greenhouse gas emissions and removals, and how are we doing. And I think they're still doing that, which is great, even in the current administration. And so the IPCC, which kind of oversees those principles for the accounting, a few years before that, created guidance for including wetlands into national accounting. And so, so there was a team of folks in the US who were able to do that, and that's helping get other countries interested in doing it. And the goal there is, by counting it, it counts, right? If you don't count it, it doesn't count. And so that's an opportunity to promote better management of coastal ecosystems by counting the greenhouse gas changes when you develop, degrade, or restore where you get good changes. So that's happening. Another context, and Craig mentioned this, are greenhouse gas offset methodologies for blue carbon projects. And so this is basically methodologies are how you get carbon credits for doing tidal wetland restoration work. So there's a restoration methodology in existence. It's got a fancy name, VM33, it's a short version. And that's within the verified carbon standard, and you'll hear a little bit more about that from Scott later this morning. And there's a second methodology that we've been working on, and we are getting closer to getting that approved, and that's a methodology for protecting or conserving these ecosystems. Both of these methodologies are global in scope and have a broad definition of what restoration or conservation entails, and so both of them are really broadly applicable, and we designed and developed them that way deliberately. And so this work, the feasibility work, the work that the science project has been doing, the stocks, that actually helps inform use of these methodologies. The third thing I want to point out kind of at the national and global scale is the Coastal Carbon Research Coordination Network, CCRCN. You can Google that. I didn't put the website up there. It's trying to coordinate research and data collection and analysis and interpretation of that data for blue carbon ecosystems globally, I believe. And so it's a huge undertaking, but it's much needed because there are so many people now collecting so much information and trying to understand greenhouse gas dynamics in blue carbon ecosystems. And so that's an important thing that's happening, all this coordination now of the science and the data and its interpretation, extrapolation, et cetera. So I urge you to look into that if you're interested. And then there are just so many scientific publications coming out really just about every month on these topics. And the good news is that rather than list all the publications, I'll just say, hey, there's a book. So the book was an incredible undertaking. Steve Crooks was one of the editors or chairs on that. And it's an academic level, right, textbook. Yeah, focused at undergraduate students. Some of us in the room have chapters in there or contributed to chapters, and it's a fantastic resource for really understanding just about every aspect of blue carbon that you can imagine. So there's a lot of pieces happening at this higher level, and what we've been doing here actually fits in nicely to all of them, and that's kind of the point I wanted to make.
Actually, it's also an ideal Christmas present for all the family.
It's an ideal holiday gift, birthdays, bar mitzvahs, whatever you want. It's fantastic. So Craig put this up earlier. Do we get a cut of everyone yourself in this workshop? Craig put this up earlier. The feasibility project is looking at the market feasibility of blue carbon finance for restoration, tidal wetland restoration in 3 places. And Coos Bay is one of those 3. And ultimately it's the outcomes. We can look at this list: engage coastal communities, the economic viability, understanding that, identification of emerging information gaps and approaches, and then roadmaps for potential future blue carbon projects. I actually think it's a good list of outcomes, but I want to focus on the last 2. So we'll talk more as you get the results from Lisa and Scott and Steve about what we learned we need to know more about as we go forward, as well as how could we go forward in different ways. And there are some paths that will be presented, and you'll get, we'll get to discuss those. And this is meant to be an interactive kind of workshop. We don't just want to talk at you all day. We very much want to hear what you're thinking, what your questions are, where you think opportunities might be. Is that the last one? Yeah, okay. I think that's the last thing, so I will stop there. My slide with everybody is bigger than Craig's, so maybe you can read those names now. The point is that there's people from all different sectors all across the US who are stakeholders, interested parties, end users of the work that's been happening here in the Pacific Northwest. So with that, we go to Scott. Should I see if there's questions about the overall? I did not go into like the outline of the project feasibility study, and Scott's going to go into that more. Lisa's going to go into that more. So I did not go into a lot of detail on that. If there are questions about that, I'm happy to take them. Any questions? Are we good? Should we move on? Yeah.
Since you're talking about the big picture and the global picture and longer time frames, I'm just wondering where you see this going next, broadly speaking.
Broadly, like in the US and globally, or?
The outcome of this particular, the report that you guys have in draft, when it's finalized, how do you see that specifically fitting in the puzzle piece into this bigger picture?
Right. I can say some general things. I think part of that's for discussion with you all too, and ideas that our team will bring. I will say there have been a number of feasibility studies now on blue carbon finance, right? And I should have said, so blue carbon feasibility studies, they look at the legal, the technical, the financial, and really the practical feasibility of adding blue carbon as a layer to planned or existing restoration efforts. It's not trying to, it's trying to build on what's already happening. And so will it bring an economic benefit is ultimately one of the main questions we're trying to answer. But we've done this in a number of places now, and I think that the collective knowledge now that's kind of bubbling up from all of those, I think is giving us some ideas about what types of restoration projects are going to be the best places to layer in blue carbon. I think they're also giving us some ideas. This is a good question because it reminded me of something I wanted to say. They're also giving us a better understanding of where the challenges are in working with these methodologies within the carbon standard, right? Within the verified carbon standard, it's not easy. We're not going to pretend it's easy to do a blue carbon project. Methodologies are complex and have a lot of requirements. And so we're identifying now kind of where some of those sticking points are. The verified carbon standard has just, I think it just closed, but they put out a call for a blue carbon working group. So they want to try to promote, I'll say more because there haven't been any yet, restoration blue carbon projects, right? Getting credits. They want to promote that. They want to figure out how can we do it well, but make it easier so that people will actually undertake these projects. They have an interest in doing good projects for ecological reasons that have a climate change benefit. And so they're forming a blue carbon working group. I think probably most of us on the project team are going to be part of that, and some other folks. So that's also the kind of information we're getting from here is going to feed up into that as well. Does that kind of answer your, okay, all right. Okay, should we see if there's questions from the phone? Okay, I don't know if we have to push any buttons or anything. Okay, are there any questions from those conferencing in?
That would be a no.
All right, silence is always a no.
Well, good morning. Like I mentioned earlier, my name is Schile-Beers. I'm on the technical side of this carbon finance feasibility project, and this has been a really unique experience for me as someone who is usually collecting the data that go into these more applied studies, to have a more holistic approach or a sense for how what you collect on the field, on the ground, can actually be applied to a broader scale. So this has been a great project to be a part of. So we've seen this map before of the sites that we were focusing on, but within the larger context of the Pacific Northwest Blue Carbon Project, we were focusing on 3 sites. within this. Up in Oregon, Skagit Bay, the Snohomish Estuary, and then here in the Coos Estuary. And we were interested to see if there was the potential to use carbon financing as a source of revenue for restoration projects. And we had to use a standard, a methodology, the verified carbon standard, and it is a very rigorous methodology to use. But that's the one that we've used. And so we wanted to examine the potential for, like I said, using carbon financing and restoration. I'm going to present the summary of our findings of our greenhouse gas emissions and removals for each scenario, and then give an estimate of any carbon offsets that might be generated through restoration. And so in all of the situations, we're looking at two different scenarios. We have our baseline scenario, so this is just business as usual, no restoration action, and we're looking at above and below ground biomass, and we're looking at also fluxes of carbon through carbon sequestration in the soils, and also emissions through methane and nitrous oxide. And then we're also doing this in the project scenario. So this is with some sort of restoration activity that brings tidal flow back in and it starts to function like a wetland again. And for a project to be successful, it's from a carbon finance project, the with project scenario has to be sequestering more carbon than under the baseline scenario. And there's a variety of trajectories that you could look at over time, but basically you want to be in the zone of blue on this graph, where your with project scenario is sequestering more carbon. Once we had our first round of workshops in all of the estuaries, we decided that the best approach was to not specifically look at certain sites or certain restoration projects that were planned, but instead to examine like a generic scenario of what a restoration project would be like in each of these estuaries. And so I'm just going to review the different scenarios that we examined. So starting up in the Skagit, our baseline is former agriculture. So it's a highly productive system up there, currently a lot of farming going on. And I should note that with any project, for a carbon project, that the land has to be not in use for 2 years prior to the project. So you're not disrupting any sort of financial activity that's going on or operations, because you have to say that with this project, the activity isn't just moving somewhere else as a result of the restoration. So in this former agriculture scenario, it's seasonally wet. With fresh water, there's low herbaceous biomass, and a potential project could be a mesohaline tidal restoration. So this is salinities from about 5 to 18 parts per thousand. Initially, the cover will be with your basic brackish salt marsh species, or brackish species, common three-square, bulrush, and you'd have low methane emissions. Another scenario that we looked at, applying more in the Skagit, is the same baseline scenario of former agriculture, but then also looking at a restoration with a lower salinity, so oligohaline, so about 0.5 to 5 parts per thousand. Initially, it's covered by Lyngby sedge, and there's moderate methane emissions. Moving a little bit south to the Snohomish and the Coos estuaries, our baseline is a former pasture. So this has low grass growing on it. In some cases that we found, actually a lot of cases, it's dominated by the invasive reed canary grass, which that opened up a huge can of worms that we weren't quite expecting in this analysis. And then with the project scenario, we examined oligohaline tidal marsh, so a lower salinity, same conditions as up in the Skagit, with moderate methane emissions. And then we also looked at tidal freshwater wetlands, so that would have initial coverage of the Lyngby sedge and moderate methane emissions. And then finally, we saw some opportunities for this in the Snohomish, but also could be relevant here about restoring tidal swamps with Sitka spruce. And we looked at 2 different scenarios with different coverage of the trees, so 1/3 coverage and 2/3 coverage, to see if that would, how that might affect a carbon project. Just to go straight into what our key findings are, most of the scenarios that we looked at did not result in the creation of carbon offsets. So that means that with restoration, there seems to be more emissions than there are removals in the time frame that we're looking at. In our analyses, we were only going out to 40 years. You know, this is pretty myopic in the grand scheme of restoration about the potential for wetlands to store carbon. But within the specific scenario, 40 years, we did not see that. And we were finding that because most of these sites are river dominated, what was influencing the emissions was methane, as that was outweighing any sort of carbon sequestration within the soil or within the plants. Although we did find that in the 2 scenarios that we examined with the incorporation of Sitka spruce restoration, that there was generation of carbon offsets, and that just within the 40-year time period that we looked at, that there was more sequestration in these systems than emissions. And then also compared to the baseline scenario. And we also realized that there's a lot more research that needs to be conducted with the invasive reed canary grass. It has super high productivity at sites where there were soil cores taken and looking at carbon accumulation rates in the soil, that it's actually accumulating carbon. That was something that we weren't quite expecting. We were kind of thinking that maybe in like in an agricultural situation where something's getting tilled on a regular basis, that there wouldn't be a lot of carbon, but it is appearing that in these sites that have reed canary grass, there is carbon storage. And so in your baseline, you're already having some storage going on. So we definitely need to investigate this further and see the impact of reed canary grass on methane emissions as well. So just to go specifically more into the Coos estuary with our sites, in our baseline scenario, we were looking at abandoned or inactive pasture land. And since a lot of these sites have the reed canary grass, we're assuming that there is some sort of baseline carbon accumulation rate in the soils. So these sites are seasonally flooded by freshwater, and there could be leaking tide gates that make this flooding happen on a more regular basis than just with rain. So we are assuming either it's a short-statured grass or the reed canary grass. And we were fortunate to actually have locally collected methane and nitrous oxide data. That was an issue that we had in our other estuaries, that we didn't have this data locally. And it's a pretty impactful aspect of this analysis to know how much methane or nitrous oxide emissions, because methane is approximately 25 times more the global warming potential compared to carbon dioxide, and with nitrous oxide, it's almost 300 times as great. So this is super impactful, and so we need more information about what methane emissions are in their baseline conditions, and also in our restored and natural sites. Like I mentioned earlier, with the reed canary grass, it is highly successful at invading and growing in our systems. It's hard to remove once you have it, and it tends to dominate more in freshwater conditions, so once you introduce some saline water into it, it could die off, but still it is highly productive. In our restoration scenarios, so we are looking at the oligohaline marsh, so lower salinities, initially dominated by Lyngby sedge. I know over time and with different elevations, you would have different plant communities, but just for this initial feasibility assessment, we just considered this plant. It does have a lot of biomass as well, so that is something that's positive from a with project scenario. For the soil carbon accumulation rates, we were using data from the Snohomish estuary at a restoration site that was accumulating a lot of carbon in the soil. One thing that I haven't mentioned so far is this allochthonous carbon deduction. So if carbon is coming into the system and it's bound to sediment and it's getting stuck or it's getting sequestered within these systems, since it wasn't technically produced within the site, it doesn't count towards carbon generation within the project. And so you have to deduct for this coming in. Sites that are more minerally dominated, there's a higher deduction because that means there's more sediment coming in from outside of the system. If it's more peat, or there's a lot more, some more peat or more organic material within the soil, then that's assumed to be produced within the site. And all of the estuaries that we're looking at, they're highly minerally dominated. And so there's a quite large deduction. As you can see, it's 43%. And this was based off of soil cores that that had been collected within the region. And that's one of the reasons why we might be seeing that there's more carbon being accumulated, or there's the with project scenario isn't quite as favorable as with the baseline scenario, is this large deduction that we're having to account for. And we also were very fortunate to have the methane and nitrous oxide data collected locally so that we have a better idea of what that's like in the system. And we were also looking at a mesohaline, so higher salinity marsh, with the same scenarios of the plant, the soil carbon accumulation rate, the allochthonous carbon deduction, and some slightly different methane and nitrous oxide values. I'm just going to walk you through the summary slide. So the total baseline soil removal, the first line, that is incorporating the soil carbon accumulation rates, if there are any, and also the trace gas emissions, so the nitrous oxide and the methane. The line below, that's for total project, so that's the same data going into it, only with the with project scenario. The net emissions reductions or removals, that's the difference between the two, the project and the baseline. The next line down is for biomass. And net emissions reduction is the difference between with project and baseline, incorporating the biomass. The non-permanence buffer, this is considered like a little reserve that you keep off to the side in case there was some leakage that was going on, or if there was something where there was less carbon being stored with the project than expected, so it's just kind of like a little reserve taken away. And then the carbon offsets is what would be generated if this was deemed to be a successful or a good project for carbon offset generation. So to look at the first scenario, the tidal oligohaline marsh, basically we're seeing that there are more emissions than removals with the project scenario, so there are no carbon offsets generated. And this was the same case for the tidal mesohaline wetlands. One thing that was interesting is looking in general about the Coos estuary and then the other estuaries is that it is river dominated. And a lot of the potential restoration sites are in the stretches of the estuary that are lower in salinity. It would appear that a restoration project, a higher salinity, like in a salt marsh, or a higher salinity brackish marsh, would be more likely to produce carbon offset generation, just because there's less methane that's being produced, that at about 20 parts per thousand, so about 2/3 that of seawater and stronger. The methane emissions are basically considered negligible because of just different microbial processes happening in the soil. So you would not have that big penalty of sorts with the incorporation or with the methane when you're having a restoration site. And we found this to be the same not only in the Coos estuary, but also in the Skagit and the Snohomish, that the restoration opportunities are just in fresher areas. But since there is such the potential for methane to influence the results of this analysis, we did a sensitivity analysis to look at, so if you had lower or higher methane emissions, how would that affect offset generation? And then also with this surprising finding that you could have carbon accumulation in your baseline scenario. So what would it, if you were to play around with these numbers a little bit, would that affect the carbon offset generation? And this is basically the sweet spot right here, where you have no baseline soil carbon accumulation and you have very low methane emissions. And under this scenario, you would see carbon offset generation. But as your baseline soil carbon accumulation increases, you have less offset generation. And then also as your methane emissions were greater, you would have fewer offset generations. And so this was just important just to realize how influential these two values are in these analyses, and then how important it is to try to collect local data so that we have a better sense of what is going on before a carbon project could be initiated. So this was for the mesohaline wetlands, so the higher salinity one, and then also for the lower salinity, see a similar trend that with no baseline soil carbon accumulation and low methane emissions, you could potentially have carbon offset generation. I just wanted to just look quickly at the Snohomish estuary, just to give you the example of the scenarios where we did see the potential for offset generation. Within this estuary, it was historically the majority of it was Sitka spruce, so it was wooded marsh. And currently, there is a lot of agriculture that's going on. There's a lot of abandoned lands, and then also some pasture lands. And in this situation as well, this was a site that we had visited, and this is all reed canary grass. So it's a similar situation as here, where there's a lot of carbon accumulation in your baseline scenarios. But with the Sitka spruce, so it's a lower salinity, and we were looking at either coverage of 1/3 or 2/3 of the site. Just looking at aerial imagery of intact sites, we didn't see that there was complete coverage in any of the sites, so this seemed realistic. We looked at growth curves for Sitka spruce over 40 years. We don't know if the data going into these growth curves were incorporating trees that were growing in wetlands or if they were higher in elevation. So this is still a little bit of an unknown whether, like, how reflective this is under marsh conditions. We used a soil carbon accumulation rate from within the estuary. The Loch Lynnis carbon is a little bit lower because these soils are a bit more organic. And then we used the methane and nitrous oxide emissions collected in Oregon because that was the closest data that we had to these sites. And so this is definitely something that we need more information on, is what local variation in methane and nitrous oxide emissions. And basically, this is the same summary slide as I showed you before. But in these two scenarios where we have a 1/3 and 2/3 coverage, we are seeing offset generation. And we're looking, I forgot to mention this earlier, that we're looking at a site that is 100 hectares. So it's a modest-sized restoration project. If you had the opportunity to group multiple restoration projects together under the same carbon finance project, that could lead to the potential for more offset generation. And it would also state that, I mean, even though it does seem optimistic that with the restoration of Sitka spruce that you do have carbon offset generation, it could be a little bit trickier to get the conditions correct for this to be a successful restoration project. They have to be a little bit higher in elevation. The salinity might have to be, or you just have to have the right sites for it. And it could be an initial larger amount of money that's needed for these restoration projects to be successful, but there is the potential for carbon offset generation. I also want to say that just because with our analyses or our findings that it doesn't seem that this is that optimistic in the Pacific Northwest, there are so many other reasons to restore wetlands outside of carbon. All of the other co-benefits with other species, with fish, water quality, etc. So by no means are we saying don't restore wetlands. And this is basically the same sensitivity analysis that we did here, but there's a lot more potential for carbon offset generation with the incorporation of trees. So just to summarize our key findings, we need a lot more data on trace gas emissions in our systems, not only in natural and restoring sites, but also in our baseline scenarios within agricultural lands and pasture lands. We need a lot more data on soil carbon accumulation rates, both in project and baseline scenarios, just to get a better sense for the effects of different species on soil carbon accumulation rates. And then also, we need some more data on reed canary grass to just understand its dynamics in these systems and how it's affecting carbon fluxes. And with that, thank you, and I'll take any questions.
The question regarding sea level rise, how does these affect, does sea level rise affect these calculations as they are, or is this not factoring in sea level rise?
So with the... Can I just interject one thing? For the sake of the remote folks, if you could repeat the question. So the question was regarding the influence of sea level rise in these calculations. For this feasibility assessment that we did, it did not incorporate that, but with a normal project development report, you would have to analyze the effects of sea level rise and how that might affect restoration success within the project, and then also how that changes in the water could affect baseline scenarios as well, but that we didn't do that for this.
Thanks.
How did you come up with the percentage for wetlands carbon?
We were looking at soil cores collected within the area. So we looked at below the rooting zone, the percent organic carbon, and there was a relationship that was developed in a Needleman et al. Paper looking at soil organic carbon and the deduction that, or the assumption of how much allochthonous carbon would be there. So we used that.
Do you know how the carbon offsets you showed for the sitka spruce relate or compare to upland forests in this area?
So the question was how these offsets compare to upland forests, and I don't know the answer to that. Perhaps Scott might know.
Yeah, it would be hard to say. It's really site specific in what you're planting, and I don't think there's a lot of. I mean, you wouldn't. You know, there's no trade-off, or there's no decision in the landscape whether to plant upland forest or tidal marsh, so they're not sort of independent. So. Not sure. I would say just generally, I mean, if I were to comment generally, restoration is one of the harder projects in any carbon offset scenario, because just there's a time lag, and you've got costs up front to restore the land. It takes time for the restoration to take hold, and in the carbon markets, the benefit we see from carbon removals is delayed. And so, it's often, in a forested system for the first 10 years, you might see very little carbon being accumulated, and it's sort of, once trees hit a certain, growth stage, they start to grow. So that's always, from a financing perspective, what can carbon bring to that is something people are still trying to figure out. And, I mean, the good news is that people, from a scientific perspective, there's been a lot of science saying carbon removals has got to be part of the long-term climate strategy. So I think people have, in industry and policy environments have heard that, and they're trying to figure out how do we maybe adjust some of the carbon accounting, or how to develop new structures that would front load some of the financing to help incentivize more projects. And some of the working groups that Steve mentioned on blue carbon, they're having the same sort of working groups when it comes to some other types of the land-based carbon market that have been slow to develop. So I think there's more to come there, but it's a fact, you know, in this feasibility study, I think we made an assumption that it took 5 years to reach sort of a restoration where it starts to sequester carbon at these sort of rates that Lisa mentioned, but that's gonna vary site by site and based on elevation. So you know, these are kind of rough numbers to illustrate how it would work, but each site would need to, you know, look at it more specifically.
Well, so in terms of the greenhouse gas flux measurements, they all came from emergent wetlands, as far as I know, right? There were no actual measurements of greenhouse gas flux in a forested wetland. No. Okay. And one thing that concerns me, and I think we just have to keep at the top of our minds, is tidal forested wetlands don't only occur in the fresh water. There are many, many examples. Perhaps the bulk of the area on the outer coast was actually mesohaline in summer. And so we have a lot to do to understand potential flux in those systems.
Right, and there's also the potential for there to be emissions from the trees themselves too. And that hasn't been investigated that I know of with this particular species.
Hey, Chris. Yeah. So Lisa, methane emissions were clearly like an important driver in terms of the overall results. But I was reading through the draft report, I was also struck at how that assumption of baseline carbon accumulation also was a big driver. And I was curious if you had good rates from reading the drafts, or if you feel kind of uncertain about those. And then the second part would be, are there any data on sequestration rates from abandoned agricultural lands that are not reed clearing grass, that are tall fescue or some other species?
So we, within the Snohomish blue carbon assessment that was conducted in like 2012, 2013, there were some soil cores that were taken within different sites, degraded sites. The one site that had reed canary grass, if I'm not mistaken, Katrina, the core didn't turn out right. Like the analysis, you couldn't get a carbon accumulation rate.
Or to get a good rate, the reason they wanted to post if it's been sold or somehow disturbed. But there were a few other sites that were not reed canary grass as well.
But you wouldn't get a good rate if it's not accumulating carbon. Easily.
Right, yeah, that's it. But I did have a couple sites though that they showed an exponential decay curve, but it was just like reflected in.
But that is definitely a big gap in our data knowledge. Just having more sites in the baseline scenarios.
My question was actually related to that. I was wondering, most of these sites were formerly marshes, so they wouldn't have been accumulating carbon, and I wonder if you had teased out what portion of the carbon accumulation had been since they were diked versus before that. I think in most cases, we couldn't really see that, or we never got to a point where it looked like it was. Yeah, that seems like something that would need to be taken into account, because they were obviously accumulating carbon a lot prior to the United.
And I know with some with the Laura Brophy's cores taken within some degraded sites, that you did separate out recent and long-term carbon accumulation rates at a few of them.
Yeah, it was probably, those may not be typical though. I think those were some sites where we may have seen some major river flooding events, and the samples that contributed strongly to those recent accumulation rates might have been closest to some flooding deposits. So it's really difficult to take small data sets and try to use them to think broadly about all sites in the Northwest.
So 2 pastures in Coos Bay, and just had a 10 centimeter, 15 centimeter egg horizon, and then it was clay, so it basically looked like pasture. So they probably had lost whatever carbon they had had by that point, because they've been dying for a really long time.
And how long do you think, like over 100 years?
One was from the 1930s, and the other one was from the 19th century.
So this question of carbon accumulation, in part related to weak area grass, and any other grasses that come in, but weak area grass is particularly aggressive.
Can you speak up, please?
Is a big question. So, and we don't have much data. And you know, one of the assumptions made, one of the questions we had, which we didn't have an answer for, was does it eventually saturate? You know, do you start enriching the soil column in the A horizon, and then it reaches a dynamic equilibrium, and then you don't get more carbon accumulation with time? This was the point that Laura brought up in our discussions when we were trying to think about this. Whereas the tidal wetland, it continues on for long periods of time. And so, when we're comparing here, we might not be comparing apples to apples in this case, because we don't understand the carbon dynamics within the baseline very well. What was clear though, or what was observed, when we were in the Snohomish, when we were in the Skagit system, which is a heavy agriculture, that system has been completely nuked of carbon. It is mineral soils all the way to the top. Everything's been extracted out of that system. And when you go to the Snohomish, which is a lot wetter, that system is full of carbon. The dike lands, which have been abandoned, it's a very carbon-rich system, which is clearly feeding through the food chain in every way. And so, possibly one type of project would be, if you had it, to go from ag land to grassland and make that part of the project, then to wetland as part. So continuum. So you're not comparing a grassland or restoring grassland against a wetland. You're trying to compare it against an ag land if you actually have ag land in your system. So, but we do need to have more understandings of both the methane dynamics in these systems and the carbon accumulation within the baseline.
Also, I think if you started with a much wetter baseline condition, because in some cases the dike areas are freshwater wetlands, is they've made large amounts of methane already, and that actually might make the methane go in the right direction. That wasn't the case for these sites.
Yeah.
And one thing that I should mention too, that say if you're talking about pasture land as your baseline scenario, this doesn't take into consideration any of the emissions that would be coming by having cattle on the property, because you're assuming that there's no activity on this pasture for 2 years. And this was something that got brought up in our Snohomish workshop, that it seems not quite right that the antecedent conditions within this baseline scenario aren't being taken into consideration, like the carbon that was already lost within the system, or the activities that were occurring, like with either cattle, or if you're adding nitrogen or fertilizers to the soil. That's not factored in, and that would definitely change the with project benefit, I would think, but that's not currently within the methodology.
Lisa, I have a question, just sort of a general question. I've been thinking about this a lot since the Snohomish workshop earlier this month, and I think we all are really aware that there's a very tiny data set for the Pacific Northwest wetlands, and there's a lot of extrapolation that has to happen to do this sort of preliminary type of assessment, and things like the allogenous rate assumption and the gas fluxes and the tree growth rates and all those things. So I'm just wondering how you guys are planning to kind of coach this in terms of the public, more public than this presentation of your results. I'm quite worried because there's so much public conversation. I mean, I think it's going to be a hot topic, hotter than our stock study. The media is not going to pick up our stock study. They might pick up what you guys are going to put out. And I'm worried that it will become the accepted wisdom, even though all of us in the room know that
a lot more research needs to be done to really fully understand it. I'm wondering how you can forestall that and instead encourage greater, effort in the future to get the data that you really need to do this more adequately.
Yeah, that's a really good question. We are going to have to think a lot about this one in terms of messaging. And I think maybe what we'll do is we'll focus on the sensitivity part of it and focus on the lack of data. We've identified a lot of data gaps as part of this, but also I think what we might also emphasize is in these kind of analysis, you assume a lot of conservative assumptions, and then if you get to the other end and you've got a project, then you've probably got a very good project because you're being ultra conservative in every step. And what we're finding is there are data gaps as we're going through this, and when you look at the sensitivity, maybe as you're looking at some of these data gaps, you find out that they're actually not problems, or maybe it's not.
So it's almost like a cumulative uncertainty that's growing on itself and making it worst case scenario.
Yes, we've gathered nervousness as we've gone along until we become a nervous wreck by the end. And maybe we need to try and work. We do need to work carefully on the messaging in this one. And Steve and I are going to be in DC in like 2 weeks, so we need to work on the messaging very quickly.
Well, if there's anything that we can do to help in the research community, I'm sure that we'd be glad to.
Yes, we will do your best. Highlights would be great.
Hey, Steve, you might recall that in the comments we talked about before these meetings, I was suggesting that maybe we don't call this a feasibility assessment, that we just put the uncertainty right in the title and call it a data gaps assessment or something like that. Just because that's the first thing that people see, and if they see feasibility assessment, they might not get the part where this is preliminary, et cetera.
Yeah.
Just in terms of messaging.
Yeah, no, maybe let's look at that. But also, I guess we have to think about what we're contracted to produce. So we'll talk about that.
We can work on that.
Okay, good.
From just my looking around here, there's two conditions that will help you. One is many of the pastures do not have green canary grass, and my guess is sort of relatively stable, zero carbon. The same can you expect in most pastures. And the second one is when we look at methane in polyhaline marshes around here, it's really low, much lower than we're using here. So if you're at, really pretty strong salt water and things, I think the methane becomes much less problematic. Over 20 parts per thousand, over 8% or so.
Any questions by anybody on the phone?
Okay, I think it's time for a break. So 15 minutes, we'll